Okay, so in this tutorial we're going to look at making buttons and sliders, and we're going to also um, switch between scenes. So I have in my assets folder, and also please make sure that you have also organized your assets nicely and you have these folders. You might not have standard assets, that's because I imported it, but the rest you should have. Okay? In my scenes folder, I've got the scene that I saved, and I'm going to create a new scene. So I can create, with a right click, a new scene here. And I'm going to call this level loading scene. This is going to be like a title screen kind of scene. At least a template for one. So if we, and I'm also going to go ahead and create another new scene. I'm going to call it, I often just call it numbers, scene 1. So I'll just save that. Level loading scene. And it should have absolutely nothing in it, and that's good. What I'm going to do is create a button that loads a level. So what we're going to do is we're going to need to create a UI, a user interface. So we're going to go to Game Object, UI, and then you need to create a canvas. And a big blank square or rectangle appears. And you can see that as I scale my game window, that changes. This is actually a representation of the screen. Now, you could have a whole bunch of 3D objects somewhere in this scene. It doesn't matter where this appears. This will always just render to the screen. It doesn't matter if it's pulled around, or actually you can't even move it. So there, that's easy. Now, the canvas is where we put all of our UI elements. And you can see that there's some inputs here where you can change settings. We're going to add a button to our canvas. So we're going to go Game Object, UI, Button. And you see that a button appears. And if you move that around, you can see where it changes on the screen. Now, you can do a number of things with this button that I'm not going to go through in this tutorial, but you should be able to figure out with not too much difficulty. You can, of course, there's obviously some main settings, like you can change the color, you can change the image, or the sprite it's called, you can change the material that it's rendering with, you can, and there's a number of other options. Oh, actually that's an image, and then you can also change the buttons here, very easy. But we want to load a new level when we click this button. Another thing you can do with Canvas is you can add things like in the UI menu here, you can add text, image, and we're also going to look at slider later. So if you want to have a big title on your opening screen, you can add text, and if you look up in the inspector underneath the canvas, you can move that around. You can change the font. To change the font, you have to actually bring the font file that you download from the internet somewhere into your project. And of course, if you type here, you can change it. And you can even use scripts to change that in real time, but we won't do that today. So let's load a new level. To load a level, we have to make a little script, and we have to put it on an object somewhere in our scene. So I'm going to create an empty game object, and I'm going to call it it's appeared in some weird location. Let's bring it back to 0, 0, 0. I'm going to call it level loader. You can call it whatever you want, it doesn't really matter. We're going to go to our scripts folder and we're going to create a new C# script, and we're going to call that level loader. And let's open it up. And you see it comes with, of course, it's got our, just as a bit of a revision, it comes with our using and then the namespaces that the script needs to use, and these are the default ones that it comes with. The class name is level loader, which has to be the same as the file name, and then it comes with two different inbuilt functions, the start function and the update function. We are not going to use either of those. We're actually going to make our first function, our own function, that doesn't happen unless the button is pressed. We're going to call that void load level. And when we create a new function, we need to open and close the function as well. And then we put each of our instructions for what happens when this function is called in between those brackets. And this one's really easy because it only has one line. It's going to be called scene manage. Oh, actually, I think we need to go using Unity engine dot scene management. They changed that, and you have to now, if you're going to use level loading functions and that sort of thing, you need to actually tell the script that it's using those words. We're going to go scene manager dot load scene, and then you can see when you write a function, this is actually a function within a function, we're just calling it in a name from this script. It always gives you some options, if you look here, for what you can enter into it, and you can find those on the documents as well, on the Unity scripting help website. You can either put a string for the scene name, or you can, it's not letting me do that, but you can also put an int that represents a number that is associated with the scene. So I could put 1, and that should work. Now, so because I'm going to load scene 1, if you look here, I've called that number 1. It's called scene 1. That should load it, but it isn't going to work yet. We need to do a couple of things. We need to go to our file menu, and we need to go to our build settings, and it says here scenes in build. This is basically the scene manager. So if the scene isn't listed here, it won't be able to find that reference that we're looking for. So you have to go add open scenes, so whatever scene you're currently opening, it adds it here. And then we need to save this scene and open scene 1, and then we need to open that one. So I'll just repeat that because you might have missed it. I closed my loading scene and saved it, and then I opened scene 1, and I went add open scene to add it to my scene manager here. And actually, what I'm going to do is I'm not going to call it 1, I'm going to call it level 1, so that we can distinguish between the string and the int. So I can use a string, level 1, like that, or I can not use a string and I can enter an int like that, because actually usually I use the integers, because these numbers here, these represent each scene, so you can just put a 1. Okay? If you wanted to, for example, you could have a public variable, a public int, and call it, level 2 load, and then you could change, if you had multiple scenes, you could change this variable to be different ints, and then instead of here you could write level 2 load, and it would load that number. So let's have a look. We can close this now, we don't need it. We need to load our click back onto our level loading scene. Go to our level loader. We need to add the component, so we can add the component and go, what was it called, level loader here. And then, because I made it a public variable, I can actually put that there, and it will load whatever that variable equals here is what it's going to load. So, it's still not going to work because our button is not calling that function yet. And I want to just draw your attention to, because this is a custom made function, and also we always start function names with capital letters and variable names with lowercase letters. It only happens when it is instructed to happen, whereas if we had void start or void update like the script came with, we remember that void start happens when the scene loads or when the object appears that the script is attached to, and void update happens every frame. So we don't want it to do either of those, we only want it to happen when called. This is very easy. So our level loader is attached to our object level loader. Now we're going to go to the button in the canvas, and we need to tell it what to do on click. We're going to go add, and here it asks for an object, see? And so the object that we're going to find the function on is the level loader. We're going to put that in there. Then it says no function, and what you need to do is look inside the script that we've called it. This is actually referring not to the object level loader, but the script level loader that's attached to the level loader object. In here we should find the function we made, but oh no, it's not here. Why is that? It's because just like variables, we can make functions public or private. So we need to make our void, which is our function, public, so that other objects can see it. So save that. This time when we go to our function, we should find it in here. Here it is, load level. Okay, so we can save that. When we press our button, we play, we press our button, this should disappear because it's loading the next level. And I am so happy that that worked with absolutely no issues. As I always am. When we're doing scripting, it's like magic when things work perfectly. Okay? So that's how you load a new level, and of course you don't have to do that with a button. You could call that with a key press or a mouse press or whatever you like, just like last lesson. So you can use the canvas elements, the UI elements, to style this opening scene however you like. And now we're going to move on to something else. So we're going to go to level 1. I'm just going to set up a basic scene here. I'm going to create a cube, make sure it's at 0, 0, 0. I'm going to make that a bit bigger. I'm going to move my camera up. And we're going to, first of all, make an object that reacts to a click. And we're going to do a click and drag. And then we're going to do a slider as well as another button. Okay, so let's just make I'm just going to work with spheres today. You can use any of the meshes that you've got as well. It doesn't have to be a sphere, it could be anything. And we're going to make this so that when we click on it, something happens. So last week we did key presses, now we're going to do clicks. So, I think what we're going to do is make it change color. So we're going to go to our scripts folder and create a new script. We're going to call it click color, and you know, I always use usually when I use English, UK English, so I use UR, but because all of the coding uses OR, I'm just going to use American spelling. And we can, the interesting thing about colliders, so you see that this sphere has the collider attached, is that colliders pick up mouse information as well. So if you want something to be clickable, you just give it a collider. The other thing I didn't mention last week is you can make something solid but invisible by turning off the renderer. So if you want there to be a physical object that things bump into but you can't see it, all you need to do is turn off the renderer. But anyway, we don't need to do that now. So there's a number of things we need to do to set up a color changing script. First of all, we need to create a variable for the color, public color, and we're going to call it color to change to. So and this is the color we can choose in the inspector because it's public. We also need to do something else. We need to tell the object what rendering information is it going to change the color in. So we need to get this object's material data to be able to change the color, and actually because this is the default material, I'm going to actually create a new one to use. I don't think we need to do that, but I'm going to do it anyway. I'm going to just call it test material. Put that on here. Yep. And for some reason the lighting is making everything kind of brown even though it should be white. Not sure why that is. And you know, we could go public public material and do that. We could call it well, let's try that actually. I'll try it this way first and then I'm going to do it a more complicated way, but a better way than this. And we're going to go, there's a couple of ways we can do this, but we're going to go void on mouse down. I'm just going to check that that is now possible. Yes, void on mouse down. It's, so this means when the mouse button is pressed onto it. You've also got on mouse over if you're hovering over it, and a couple of others. We're going to go material dot color equals color to change to. I feel like this is too simple and it's not going to work, but let's see. Oh, I haven't put my script on it yet. Where are we? Click color. I'm going to put that on the sphere. So the color is going to change to, let's make it a bright red, and let's make sure that the material that it's changing is the test material. And that actually worked. Amazing. So that worked. But a better way to do this, if you wanted to set it up on multiple objects, The other thing it does, it's permanently changed the color of the material because it's in the library here, so that's not great. So what we're actually going to do is, instead of setting the material there, we're going to go void start. We're going to tell the object to find its own material value on start and store that. So we're going to go public material, we're going to call that material, void start. We're going to say material equals, so we're going to set the variable of the material to equal, we're going to call it something, we're going to call the function called getComponent, renderer dot material. This means I'm actually going to change the variable name so you don't get confused. You're going to call it this material. So this function is saying when we start the object, find your own material and set it yourself. And in that case, we don't need to set this variable public. We could make it a private variable so that we can't actually change it in the inspector, and it actually finds it and sets it itself. I'm just going to check that that worked. Let's try a different color so that so that works. So let's try on mouse over, for example. That doesn't work. Another way you could do it is void update. Check this every frame, although this is probably better, not as good. You could go if input.get mouse button, let's say down, and then you have to open the brackets and put an integer that represents the button of the mouse, so 0 for left click I think and 1 for right click. If it detects the input of a mouse button, then change the color. Oh, I have to change this every time. I'm going to fix that in a second. And then that works. If you want to check which of these is actually working, you can do this to grey out an area. So now only our update function will work. Yep, that's working. Let's try. I'm going to try something here. If the mouse button is down, change it to color to change to. Otherwise, make it the original color. And we're going to make a new variable, public color, original color. And instead of setting that in the inspector, actually I am going to make that private as well. And I'm going to tell the script to find its own original color. We're going to call it original color equals getComponent renderer dot material dot color. So when the object comes into existence, find the value of the material that is attached to it and make that the original color. So here we go, if the mouse button is down, change the color to the color to change to, and at the end of the bracket I'm going to go else, which means otherwise, if it's not detecting a mouse button down, this material dot color equals original color, and I need to close that bracket. Fingers crossed. Okay, so it's red at the moment. Not yes, it does work, but it's happening so fast that it's going back, so we need to limit that somehow. So we could, I'm actually not going to do it that way, it's too complicated. Okay, I figured out a better way of doing it. It wasn't working before, but now it's working. I have changed this. I'm not using the update function because it's not a good example. I'm going to use two different functions, and they're very simple. Void onMouseOver and onMouseExit. This means when the mouse hovers over the object, and this means when it exits the object. So when the mouse hovers over the object, I don't think I'd clicked into the window before, that's why it didn't work. When the mouse hovers over, it's blue. When it exits, it goes to red. Okay? And you could do other things like this. Let's show you how a Boolean works. Let's say, for example, what you could do is you could add let's add a rigid body. And then, we can't actually enable or disable a rigid body. Well, let's say use gravity. We'll turn the gravity on when we hover over, and this is a Boolean. So let's go public. No, let's make it a private bool, and we're going to has gravity. And let's say on mouse over, we need to go has gravity equals true. But we also need to get the rigid body data so that we can tell it that has gravity is part of this rigid body. So the easy way to do that, and let's just stick with the easy way, you can also do it by finding the rigid body and setting it here. I'm going to let you do that yourself if you want to. We're going to go public rigid body, and then we're going to call it rigid body. And then on start, we need to go has gravity. Oh no, we don't have to do that. We can just go rigid body dot use. Oh, we don't even need to have that variable. Let's go like this, of course. Yeah, we don't need that because that already is a Boolean. Why is that not liking that? Use gravity is there. Lowercase u. Let's see if that works. Should work. Yep. Oh wait, we need to turn that off before we begin, and we can set that here. We can go start rigid body dot use gravity equals false on start, so it always makes sure that it's definitely going to be off. It didn't work. The variable rigid body hasn't been assigned. I just checked that down in my errors, so we need to make sure that we drag the sphere into the rigid body because it's null. There we go. So we're making stuff happen now, okay? Alright, that's enough for the just the some basic mouse functions. I'm also going to give a script. I'm not going to take you through it, but it's called the drag transform script, and this will be on Canvas, so you can find it there. It uses some of those functions, and it lets you drag an object. So have a look, open that up, and see if you can understand what's going on in there. So let's create another sphere. And let's add, and this needs to have a collider if you want it to work. Let's add the drag transform script to that sphere. So let's see what it does. So you can click and drag an object. Now, if it also changes the color, but you can turn that off if you don't want it. Just based on the knowledge of what I've just taught you, you can open up that script and edit it so that it's different. You could add a rigid body to this, and it would fall, and I think hopefully we can still drag it. Yep, pick it up and let it fall. Plonk. You can also kind of throw it by giving it velocity when you flick it. Flick. Oh, it's not really working. But anyway, that's a click and drag script, so you might like to use that. And now let's make a slider with our UI that scales an object in size. So what I'm going to do is create a UI, a canvas, and again you see that screen appears, and it doesn't matter that it's huge and over there, it doesn't change anything. We're going to add to the UI a slider, and it appears down the bottom. Bring it up here. You can put it in a better place than I have, and just like the button, you can change all the colors, and you can do other things with that, like change the skin of that slider and everything if you want to style it. And what we need to do, I'm going to do this in a separate script, but if you want to, you can always combine these scripts into one bigger one if you need to. We're going to call it slider script. We will open that up, and we're going to make the slider change the scale of one of our spheres. So I think we need to add a using here, using Unity engine.ui, so that we can bring in the slider information that needs to be there. Go public slider and call it scale slider, because we're going to scale things with it. And then we're going to tie the scale slider is a float. The slider there's actually a value within a slider. It's called slider.value, and that value is a float. That value is a float because it represents a floating scale on this slider, and we're going to make the scale of the sphere equal to the float value of the slider. So that's quite easy, and that needs to happen every update. Mostly. For most purposes it would be every update. Because as soon as we change the value, and that could be at any time, it needs to be able to change the size of the sphere. So the command we're going to put into our update function is transform dot lowercase transform, which means this transform dot local scale, and here it says it's going to take a vector 3, which, oh, it changed that. Why did it change that? Local scale. Don't change the lowercase. Equals, ooh, why? Oh no, it is lowercase, sorry. It was red before. Equals new vector 3. Now, this is something that C# does that kind of the JavaScript will let you get away with. You could just go transform local scale equals scale slider maybe in JavaScript, but here you need to store the new value that it's changing every frame into a temporary variable. So that's why we're putting new vector 3. And a vector 3 has 3 values. It's vector 3 just means any value, any data value that has 3 separate values inside it. And so we can use vector 3s for x, y, z, and all of those sort of special groups of 3 that we use in 3D. You can also have a vector 2 if you're doing 2D and you're just using sets of 2 numbers. We're using vector 3, and of course that's going to take the x, y, and z scale as 3 values. We just want to make it uniformly the same, so we're just going to go scale slider dot value, scale slider, and you can see here it's saying, yep, give us the floats, scale slider dot value, and because the value is a float, it will work, scale slider dot value. Now, let us hope that that works. Let's put that onto our sphere here, slider script. And of course it's not going to work yet because we need to connect that up to this slider, which is this one. And let's see how we go. Oh. Of course. It set the scale to be 0 because the value is 0, and then when we pull it, it increases in size. So let's change that. So if we want the minimum value to be a certain amount, remember linear equations in maths, to make it a minimum you just add something to the I forget the term for it. Let's make it plus 1. That might be too small, but let's try it. And you know, you could set a variable up here like public int minimum size, and then just go plus minimum size, plus minimum size, plus minimum size, and change that if you wanted to in the inspector. Yeah, so now it's 1. And you know, if you wanted it to be more, you could go plus 1 times 3. And that's not actually going to work. Why? Because it, if you remember maths again, it uses BOD maths. So you have to use brackets. Brackets of division, multiplication, addition, subtraction. I don't know. I'm not going to explain what that is, but I need to add extra brackets here, I think. See if that makes it. Yeah, see? It's much more dramatic. The reason that's more dramatic is because if I don't put the brackets there, it's actually calculating 1 times 3 before it's adding slider value, whereas here we want to add 1 to slider value first and then multiply that whole equation by 3. Okay? Now, if you wanted to we didn't look at this last week, but you could also transform dot translate, and then that's how you move it in space. So you could, again, equals new vector 3, or no, we could go plus equals equals, wait, no, you just put it in the brackets here, scale and then just go 0, 0. So this means it's taking 3 values, x, y, z. This means in the x value here we're going to say take this object's position, we need to go dot x, and then add the scale slider dot value only to the x. Yeah. Well, it I don't know where it went. Oh, it's because I need to I'm going to turn off that script there, because I think it was turning on the rigid body and making it fall. Yeah. Well, that's very dramatic. Let's just ignore that. Okay, so that's how you change the scale with a slider. And if you can make that slider affect any float value. All you have to do is in the update make the float value you want to change equal the scale slider dot value. Okay. Let's do something else. Let's change a random thing. Let's add some randomness. Let's make our floor change to, we'll use colors again, change to random colors. Just so you kind of know how random works. And I'm going to do it with an array. Okay? So, alright, I'll just use this sphere again. We're going to call a C# script, I'm going to call it random color. And we're going to create an array of colors. That is, we're going to be able to create a list of colors, and it's going to randomly select which color it's going to be. So we're going to go public color. And now normally we'll call it colors. Normally this, when we just go public and then declare the data type and then say the variable, this just means for one color. But you can actually do this to any data type. If you add that to the end, that's now an array of colors. That means this is a list of colors, essentially, called colors. And I'm just going to go void update here. Don't worry about these brackets. That we might go over what that means later. Let's just leave it there for now. Now you can see we need to find our sphere, and we're going to go where is it? Random color. We're going to add that to our script here, our object here. See, colors has a drop down arrow. You can size, let's say 5 different colors, and now you can choose your different colors. So red, blue, green, yellow, or pink. Okay, got 5 different colors. And we're going to say every 2 seconds change the color. So what do we need to do? Let's revise from last time. We're going to make a timer, public float timer, and then public float. These don't need to be public actually. Time out again. On the update we need to make the clock tick up, so timer plus equals time dot delta time. And then we need to go if timer is greater than or equal to timeout, make the color change to a random color. How do we get the renderer information? We need to remember to get the material. How did I do that in this one? I'm going to go private material, this material. We're going to go void start and set that material. So we're telling the script to populate this material value with whatever materials on the object. And then in our if the timer reaches what we're going to make, say, let's make it 1 second, we're going to go this material dot color is equal to colors, that's this variable, and how an array works is that it has this open brackets, and if you put a number in this bracket, that refers to whichever entry into the array represents that number. So you see how it says element 0, element 1, element 2, element 3, element 4. This is an int value because they're specific numbers. If I put colors 0 in here, this means that when the timer times out, this color changes to the 0 value in the colors array, and the 0 value is red. This is a confusing thing about arrays. You have 5, the length of the array is 5, it has 5 entries, but that means that the last entry is actually 4 and the first entry is 0. This can really throw you off if you're one number out and you're doing maths. Okay? So let's just see that in action, and of course after our function we need to make the timer equal 0 again. Let's watch this happen. So hopefully that works. Our timeout value, let's make it 1 second, and it's going to change red to red, so we need to, let's make it change to blue. So that's the second entry. After 1 second it should turn blue. Yep. But it's not random. How do we make that random? Well, we can make this integer here a random integer. We may need to set that as a separate variable first. Yes, we will have to do that. So to make this a random number, we need to actually declare a little temporary variable here. So you've got your public main variables, the important ones that are visible maybe for all scripts or just this one. You can also declare variables within calculations of functions that will only be visible within the function itself. So we're going to make a little temporary variable called, we're going to go int x is equal to random dot range, and you can see it takes a minimum integer and a maximum integer. So our minimum integer is going to be 0, and our maximum integer, we could put 4 because that's the range. But what if we kept changing the size of this array? Instead of that, we're going to put the name of the array colors dot length. So this little temporary variable x is going to equal a value that's a random range between 0, the first element in the array, and the array name dot length, which means the number of it has to be colors dot length minus 1, I think, because otherwise that could return a value of 5, and then we'd have a null value. I think that'll be the case. So be very careful. We'll check that. So then, instead of having colors 1, we need to have colors x, because that x now represents the random value. So let's try that. So it's going to go blue, yellow, green, yellow. Yep, that's working. And let's see if it ever goes pink. It's never going pink. So maybe I was wrong. And it's also never going red. So maybe we actually have to go 1. I'm not sure. So it starts red, yellow, pink, green, blue, green, yellow. Come on, go red. No. Not getting any errors, so we're not out of range. If you put a number that was out of range, you'd get an error down here that would break it. It would say array index out of range. So let's try 0 again. Yeah, okay, so that was fine. So wow, we have a multicolored sphere that can change scale and turns random colors. And of course, using what we've learnt, you don't have to have that happening every second. You could change to a random color on a click or on a key press. You could also change to random spawn points. You could move an object to other random transform locations by creating an array of transform values. Say this becomes a transform value array, and you drag all your different empty game object points into there and say change the position every second to a different location. In fact, why don't I just do that, because that's something else to do, and then we'll finish up. Okay, so let's make one more script called random location. We need to create a bunch of empty game objects. So there, and there. So there's 3 game objects at different positions. Random location. I'm going to copy the random color script and edit that. So instead of colors, we're going to go transform. We're going to go locations, and don't need any materials. we're going to go exactly the same. We're going to have a random range. Instead of colors.length, it's going to be locations.length. If the timer times out, then we're going to go transform dot position equals new vector 3 locations x locations x dot x wait, no. Transform position equals locations x dot position. That's easier. Because position is a member of transform. This is a list of transforms, so we can just make the position equal to the new position. This lowercase transform means the transform of this object. Let's see if that works. Let's go to our random sphere again. We'll just turn off these. We'll go random location. It's not working. Oh, because I copied it, it's saying the name of the thing is wrong. Location. I think it's called random location. Yep. Now that should work. Pop that there. Locations. We're going to have 3 different locations. We're going to grab our different points in. The timer can be 1 second. Let's just see if that works. Whoa! Well, it's working. But the timer was going back to 0 every too quickly. Why was it doing that? Let's not use a timer. Let's go. Actually, let's make a button. So instead of having any of this, we only need anything to do with time. Let's not make it an update. Let's go void change location, public void change location is just going to be that. And let's do it when we press a button. So in the game object UI button, we're going to call now the script random locations on our sphere, so we need to put that in there. We're going to go random location, change location. Let's see. So that happens when we press the button. Blonk, blonk, blonk. See? That works. And you know, you can have a lot of fun here. You could say if you turn the gravity on all the time, every time it would fall. So I mean, we can just try that out now. We could say use gravity. We keep making it fall from different places. You could also add a limitation in the script that said if it just went to that location, you can't go there again. And so depending on what you want to do with these scripts, you can ask me to help you if you're in my class, and I'll help you edit those to what you want. Okay, so that's the end of the tutorial for now.